from this video, I will continue the next chapter. So first, congratulations is you follow this series, then you already complete the first 5 chapters. So from here you can see we worked through together about the numbers, use the visualizing the method to do the graph and describe data with the statistics, and also talking about the algebra and the symbolic math. Last chapter we play with the sets and probability. During those chapters we learned the knowledge point, and also I try to keep your sharpened weapon to do the plotting. This chapter we will move to the drawing geometric shapes and fractals. So it's a new type of the chapter. I hope you can enjoy for this. And for this subchapter, we discuss about the initial the knowledge points, and then make our circle drawing to fill with some the different approach using this patches module within the Matplotlib. So if you like my video, welcome to follow my channel. It's here YouTube at Yasen Zhao. So then you can get those auto notifications automatically. So that within here, so within this new chapter, we will learn 3 major things. First is learn how the patches in Matplotlib allow us to draw geometry shape. So if you not draw the plotting, you want to draw shape, is using this patches module. And we will learn about animation supported by the Matplotlib. And then this last but not least, we will draw the fractal. So that fractal is the complex geometry shapes created by the repeatable application of a simple geometry transformations. So like a snowflake, that is the typical sample for the fractal. So we will play on that chapter. Then we have a few of the programming challenges, and then this all the sample codes, like we keep adding during the our demo and the practicing, is in this doing math with Python repository. From here you can see the this README in the front page with this book. These books you can get this book the bought from the online store, or you can like me, so you can check with your local library. If possible, you can book our this reserve and to read. And here is the chapter structure. And if you don't have the free plan, which I highly recommend that you install the free plan software so that you can see this the mind map in interactive way. So I actually add quite a lot the informations within this mind map. So that if you have the free plan, you can directly go through this. The file is here. And if you don't have a free plan yet, I export that to our Markdown file. So you can check with this Markdown format without any additional software. But here is just the plain text, but it's already the good enough for you. Is like last video we talked about the area of circle estimating. From here you can see I put is the reference of those the program names. So if you come to here, you can find this yourself. So let's go to our book. So this book, for the first draw geometry shapes with Matplotlib patches. This patches module we haven't yet tried before. So let's try this, just review what we have done before using the Matplotlib. So if we do this like import Matplotlib patch.py plot as plt, and then we give a toList. Maybe we give a different one. Then this, what we can do is just directly plot x, y, and we do this show. So then you get a line, so like here. So this is create a window and show line passing through the given point with x, y on pair per the tuple formats. Under the hook, when the plot function is called, our figure, this is an object, a figure object is created within which the Excel are created, and finally the data is plotted within these Excels. So that is the way or the approach for Matplotlib doing. And the following program is we will recreate this plot, but will explicitly create a figure object and add access add to it. The reason we practice this is when we're starting to draw the shapes, we need to make those figure and axis in the explicitly way. So we already load this, and we have x, y, and we define this figure as our plot plt figure. So it can be empty, this part. Then let's see figure. Figure is by default is 640 times 480. So if we see here is the type fig. The type is the figure. So that is our the figure. So and this plot, the object, we only see the line chart, but we don't see the figure because it's hidden, created behind. And we also explicitly define the access. So plt.access. So that's for both x and y. So now is we can start to do the plt plot x, y. And we do the plt show. So we also get this part. So if we put a y to another, so then we do this plot again, and we make this show. So you can see that that is looks no difference, but we are using the explicitly way. So the first, this one, we create a figure object, and then we create the Excels using this Excels function. So these two functions are new functions we are using within this PLT. And the Excel functions also add access to the figure object. The last two lines, these two lines are the same way that we did in the earlier those programs. Besides manually create a figure and access, you can use two different functions in PY plot module to get the reference of current this figure and access. You can call GCF, so that is the figure, GCA, that is the access. So if we put that is the plt.gcf, so you can see here, if you directly call that, it's the same as this one. And then this, if we say AX is this one, so if we say plt.gca, you also got this. So these two the function are give those same results. So the interesting feature for this function is each will create a respective object if it doesn't already exist. So if it's not exist yet, it will create for you. How this function work will become clearer as we make use them to the shape or drawing. So let's move to this video's program. So within this chapter 6, let's starting to create our first one. So 0601, and let's see. So our program will be this is the 0601. Then we do this first. So then we don't need to create a too deep part. It's a draw circle. Now we use draw, it's not plotting. So let's quit from the command. Oh. And make this lower. And we have our the header. So purpose example of using Matplotlib circle patch. I'm not sure why the term is using patch, but it's actually just an additional feature for drawing. So just remember for that. So what we will do is first let's import Matplotlib plot as plt. So, and we put this our main program. We want to draw the circle. So let's call something to make our program run. So first is we will create a circle, then we will show. So that is the two parts you can see here. We will use plt.circle, this function. So they have this the original, the center of circle, then radius. And the result is like here, the middle chart will be the center. And then return this circle, then we got our circle object. So actually, it's, we can directly call this here, but we create that separately. Then once we have the circle object, then we send this circle object to this show shape. This show shape is we send this our arguments, and then we use this argument to have our GCA is the access, and add patch into this access area. We then have this access called is scaled and make that. So let's see what's the scaled. We do this line by line. So then if we know this, we will create circle. So that is our first one. So let's do this circle, create circle function. So there's no argument need to be transferred. It's a circle is a PLT. We already load PLT, so that just is a circle with the center's coordinates and radius. So when you have our position of your center and the radius, you can define our the unique circle. Then we just return this, and then let's type just print C. So let's see. So what's that means? So C, you can see C is this circle object, and then let me see the type C. Oh, let me run this. Oh, there's no type C, so it's fine. So let's continue. So we define our show shape. So this kind of our standard way. So we use this patch, and then we have this. Then we load that is C. So how we show that is last is must be the PLT show. So we will define this is access with explicitly way. So PLT GCA. So this GCA is the same as this one, PLT AXL AXES. So then we let's see. So if we don't have those, we can already draw this. So GCA's result is just give this a frame, and in the backend they already create that layout or this area with 640 times 480. This the pixels, the area. Then this will add patch. So this is our new function. So add patch with this transferred. The patch is our circle. So if I run this now, so you can see here. So the circle is in the 0, and our radius is 0.5. So maybe as I put make that as a square, then you can see better view. But it's not our circle because the circle center of circle is in the origin. So we will need to have our one more. So this plt dot axis scaled. So let's see the effect of this one. So this one is make that circle scaled inside of the area of the this chart. So all this picture, and put this origin in the center so that we can see the complete shape. So through this beginning sample, so we know is if you want to draw a shape, first you need to define these shapes, the object. So we have a specific circle function to define the circle. And you send this center of circle's coordinates value and radius value. Then you create that and send this circle to as a patch. So first you define the area and define the axis. Then this through this add patch to add your shape. So if here I create a rectangle, I also can reuse this one to add our patch, and then this we use this scaled on the axis. Then they can put your shape can be see with this automatically scaled the coordinates. Last but not least is the PLT show, so you can show that in the screen. So I hope is these are you can familiar with the how to draw a shape compared to earlier we used the Matplotlib to draw the chart. So the circle doesn't quite look like a circle, as you can see. This is due to the automatically aspect ratio. So it's not looks like a circle. It's so let me run this again. So but you can put that lower and drag this the more. Oh, so these are not possible to make that because they have some aspect ratio setting like this are S-clip. So if you insert the states is AX set a spell equal. So let's make this. So plt dot is AX. Let's put that before. So AX dot set aspect equal. Let's see the effect. Function after you see here. So after 2. So I think it's that. Oh, let me add this before to see the effect. Yeah, it's still not so much like our circle. It's still the eclipse. This set aspect function used to set the aspect ratio of the graph using the equal argument. We ask the library to set the ratio of length to 1.1, 1 to 1. So both the edge color and the face color of the patch can be changed using the EC is edge color FC. So let's see. So from where I can put that. So parsing will create. So let's do this here. So FC equal to G, EC equal to R, and then add this. Oh, it's axles. So it's axis put into where? Oh, maybe this, yeah, I should put here. Yeah, so when I create a circle, I should pass this, what is this? Front is the face color, and the EC is the edge color. Let me put this. FC is the face color, and EC is the edge color. Matplotlib support a number of other patches such as eclipse, polygon, and rectangle. So we will practice some of them is later on. So you can read the documents. I will not show all of the options here. Then is you can change some more the parameters to your circle. Like is the land patch patterns or types. So that can be the make your circle is to fulfill your needs. And let's stop here. And the next video is we will create animated figures to have some more the dynamic way to show our shape. So see you in the next video.